Okay, we want to have a look at an example of an object falling under the influence of gravity, but in this particular example, the ball is being thrown up first and then comes down. So we've got a situation where we've got a up and down movement, and there is some symmetry to the whole thing. The time it takes to go to the top and the time it takes to come down is going to be the same. The velocity with which we throw it up from down there will equal the velocity or the speed, let's say, with which it returns to the ground. This all assumes negligible influence from air resistance. So the first part, how high does the ball go? So what information do we have here? We've got the initial velocity, u down here, u equals 20 meters per second. Now, in writing that down, I've already made an assumption. I've decided that upwards is positive. All right, so that direction there is positive. I don't have to make that decision, but that's what I've done. Okay, at the top, instantaneously, the velocity is going to be 0 meters per second. So we have another piece of information there. And then we've got the acceleration due to gravity. In this case, it's said to make it 10, so we'll do that. Normally, we would use 9.8, but let's use what it says. And what are we trying to find, first of all? How high the ball goes. So we're trying to find S. All right, so we need to identify which of the equations we're going to work with there. From the equations of motion, no mention of T, so V squared equals U squared plus 2AS is going to be the equation to use. So let's just extend the page a bit and carry that working on. Right, so V is 0. 0 squared equals 20 squared plus 2 times, here we've got to be careful, negative 10, because the acceleration is downwards, and so that is effectively in the negative direction because we have defined upwards as being positive, times S. All right, so coming over here, 20S equals 400, that's 20 squared, and so we end up with S equaling 20 meters. So how high does it go? It goes 20 meters upwards. Okay, now that's just a fluke, I think, that we start with 20 up here and we end with 20 there as well. Okay, so that's the vertical height through which the thing's gone. Let's just make sure we haven't made any mistakes with that working. 2 times negative 10, 20 squared. Yep, that looks okay. Second part of the question, let's just remind ourselves what the question says. How long does it take for the complete up and downwards flight? Right, well, what we want to do, this is part B, let's just figure out how long it takes to go up, and then that will be the same as the time it takes to go down. Now, what we could do, if we wanted to, make things easier, so say the time it takes to go from there to there is equal to the time it takes to go from there to there. So an easier way to do the problem would be to look at the downwards motion and say that the initial velocity on the way down is 0 meters per second. We know that the velocity at the bottom is 20 meters per second, and we know that the acceleration is 10 meters per second squared. Doesn't hurt to draw a diagram. It allows you just to put all the information down there, and we're trying to find T, the time to get from the top to the bottom, and then we'll double it. Okay, so what's T going to be? Let's see, which equation are we going to use? That's the first thing. We also have figured out the distance as well. We know that that's 20 meters. So we've got lots of choices as to which equation we might choose to use. Probably the easiest one to go for, S equals U plus V over 2 times T. All right, so 20 equals U, in this case is 0, plus V is 20 divided by 2 times T. So T equals, well, let's not maybe take too many shortcuts here. 20 equals 20 over 2, that's 10 T. T equals 2 seconds. If we had used 9.81, it would have been slightly different to 2 seconds. So 2 seconds to the top. So time up and down equals 2 times 2 equals 4 seconds. Okay. All right, motion due to gravity. Just a little bit more to do with that. Then we've already sort of hinted at the idea then that if we drop something or something reaches the top of its flight, the velocity is 0. All right, so there's a term called free fall. Free fall is talking about dropping something where we have negligible air resistance effects, and the only influence then is the influence of gravity. And in class, we're going to do an experiment to measure the value for G using this free fall approach. So if we take our equation of motion, S equals ut plus a half at squared, since u is equal to 0, that term drops out, and we can either say in general that S equals a half at squared, or if we wanted to use little g specifically for the acceleration due to gravity, S equals a half g times t squared. So if we wanted to do an experiment, we could drop an object through a given distance, S, and if we use the stopwatch to time how long it takes, we could take this equation here, we could rearrange it, make g the subject, 2s equals g t squared, g equals 2s over t squared. Or you could have said a equals 2s over t squared. So we could very easily then calculate a value for g just using that information. We will deal with that idea a bit more in class, and we'll do this experimentally. Okay, there are some further refinements to this, but we will cover those refinements in class as well.